All right, everybody, welcome to day 5. We are working on
Versus,
Python loops and data manipulation today. Um, Pretty much loops are going to be one of your most powerful one of your most powerful tools when you're dealing with programming. Is a lot of the stuff we've done has just accessed singular little pieces and whatnot. And I know we've talked about iterating through strings, arrays, or sorry, lists and other collection style statements like that. We haven't gone over how to do that. And that's where lists come into play. Let's see here. Lists actually work out pretty easily here. Or for statements, loops work out pretty easily inside Python. And from we're going to we're going to go over the for loop and just about every language has a loop like this. They tend to be called for loops. They just might be structured differently. So when we look at this piece right here, this is the actual syntax we're going to be using. Um, can somebody take a shot at trying to see if you can, given what we already know, what do you think is going to happen here?
It's gonna run an action if the whatever variable is found in the collection, right?
Well, actually,
it's
we
gonna give
we
it's gonna give you an error.
well, we're without other code, yes, this will give us an error. But you're on the right path, Marcellus, but you're what you're thinking of is probably in the next step. So this particular piece, and maybe I asked the question wrong. Um so this piece right here, it's kind of like this helps us formulate. The this is our basic structure to our for loop. So we see that the for is the keyword that starts this statement. We see the colon at the end. Item becomes a temporary variable, and collection would be it could be our string, our um we'll just talk about strings and lists right now. So for item, if collection is a string, what would item turn into? Now remember how we iterate through a string.
Would it be each character in that string?
Yes, and I see Laramie said it's going to go through each item in the collection. Let me move the chat closer so that I can
So it would
see that
index
feedback.
each thing out of collections.
Yes, so item gets reassigned each time it makes a loop through the collection. So what it's doing is, um, in this particular case, we're going to do a for loop. So for letter in, so we have my string right here. And if I print letter, right here, you see each time in each letter of the string. And that's why I placed the underscore in there, was to just make it easier to see the space. My string. So just like in the if block, we have the print letter inside this block here, inside this for block. So like Marcellus was talking about, you're going to do something for each iteration through the whatever collection you're given. Does that make sense to everybody? Any questions? So that's kind of like a broad overview. And like we've got right here, for I and X, for element and iterable. And what you'll notice is you'll notice a lot of times you'll see the letter I a lot. I usually is short for index, or you might see X, like you see right here in this one running through the through the nums list. So if we run that, we'll see that
It's just gonna do what it did in the practice section, but twice.
uh this particular one, you know what?
Because that would multiply it by 2.
Yes, it prints what's in here.
So it'd print 1, 2, 3, 4, 5, and then print it again.
Well, no, because we haven't actually printed out nums.
Oh, okay.
Okay. So I'm gonna run it here. I do not know what is going on with that, but
2,
When they
4,
print out
6, 8,
the
10.
multiplication, like each number that is going through it multiplies and then prints out whatever the I guess the sum is.
exactly. It's doing the
Uh,
multiplication because it's inside the parentheses, and when it gets that result,
gotcha.
then it prints it. Yeah.
That's interesting.
So
So
X, so with X, it represent each number automatically.
yes,
Period. Okay.
yes, that is part of how to trace out your for loop. So remember, what do we start with when we're counting in just about all coding languages? Which number do we start
0.
with?
0.
Okay. So 0 is our index here. So we start at 0, and you can kind of trace through. You could easily trace through if you want to and replace it with a number, and you could see what you'd get. It's one way. Understanding tracing through your for loop will help you with trying to debug it if you run into issues or something. Looks like. Am I the only one having issues running the code block here?
I'll check.
Seems like it's just Jupyter Notebooks because it runs in the practice file.
I was able to successfully run it.
Yours ran. Maybe there's something going on
Yeah,
with mine.
mine ran too.
Okay. Well, I'll keep copying this over to the practice file. I think that's okay for everybody, right?
Yeah, it's the same thing.
Yeah. So here's another example, but we're starting to do a little bit more complicated stuff. Anybody want to take a shot at what this is going to do?
Numbers 1, 2, 3, 4, 5, multiple numbers for X and nums. Pen. It's gonna give you more or less the same thing that you just had over there. So it's gonna be 2, 4, 6, or yeah, 2, 4, 6, and then it's gonna append those. But I forget what append does.
Okay, so append does just like what it sounds. So if we walk through the loop, our X is 1. So here, 1 times 2 is 2. So here we have 2. Now we're going to append 2 to we're appending it to the new list. So we
So,
have this list right here that starts as empty. So now,
to just add all those numbers together.
it looks like this.
Or is it gonna be 12?
We're not adding the numbers together. We're we're taking whatever is inside, whatever our index relates to inside the nums list, doubling it, and then adding it into another list or to a new list, which we have right here. It's multi-nums.
So it would just create a new list of the numbers that ran like 2, 4, 6, 8.
Yes.
Okay.
So there's our result there. And then you see we print both lists and both are populated.
So if you called for multi-nums, would it print 1, 2, 3, 4, 5, 2, 4, 6, 8, 10? Or would it
Oh,
just print 2,
we
4,
have
6, 8, 10?
okay, so let me format this print statement a little bit better.
Because I understood it like with both prints, you're calling for the original one and the appended one. But I'm just curious, like if you call for the appended one, it's just going to give you the 2, 4, 6, 8, 10.
So, oh, that's a syntax error. There we go. So we're dealing with two separate lists here. So 1, 2, 3, 4, 5 never gets added into the multi-list.
Okay.
Okay.
So when you call for the multi nums, it's just going to be the 2, 4, 6, 8, 10.
Right, because we start as an empty list right here.
Gotcha.
But because we're using append, and if we started with 1, 2, 3, 4, 5, then yes, it would combine both lists.
Wait, say that again?
If we started with a populated list, so if I add 1, 2, 3, 4, 5, because we're using append,
It would add those together.
right. So now we have a longer list. You see here?
Yeah, I gotcha. Okay, that's what I was
Because
curious.
we didn't get rid of the data, we just added to it.
Okay, makes sense.
Now that's also a key thing about when you're thinking through lists. Um, if we had something, and this would apply more like in a dictionary, but if you had my dictionary dot empty when the loop ran through all of its stuff, what would my dictionary contain? If we were theoretically dealing with a dictionary here.
I want to say,
Would it be nothing?
yeah, I was going to say nothing.
Well, if I put it at the bottom, it would be nothing, but it would only contain the number from the last run.
So it would be the multiple numbers appended.
Well, in this particular case, because it will hit that empty every time it runs through the loop. So you would be clearing out anything you appended except the last time you appended. Does that make sense?
Yeah.
So this is destructive, and the reason why I'm going over it is sometimes there's a reason why you want to have like an empty in there, but that's usually should be wrapped in an if state. But you have to keep thinking that because this is running through a loop, you have to make sure you work out, is this going to run when I don't expect it to? Like in this particular instance, we're just getting the last result. It's a cobbled together example, but it's an example of like kind of paying attention to your logic when you're writing out the loop. Does that make sense? Is that helpful, or is that just kind of muddy stuff up?
I mean, a little bit of both.
So like if
Yeah.
I went in this, if I kept emptying out this particular list or this particular list, the only number I would have in there is 10.
All right, now I'm completely lost.
So when I run it, oh, yeah. There we go. I need to refer to the right variable. There we go. Now, do you see why that's happening?
Multi nums appended 2, 4, 6, 8, 10. Because it's a last number in the list.
It's the last number, but it's the only one that remains because I keep resetting the list. Generally, this is where a logic error comes from.
Yeah, that's over my head. So because you put brackets, it like
Well, that's how you declare an empty list, remember?
yeah.
So what am I doing? The first line inside the loop, I'm redeclaring whatever's in this list is an empty list.
I get that part, but I'm just not understanding like why 10 wouldn't be gone.
So 10 would be gone if I move this down here. So now when I run it, now you see I have an empty list because the last thing we did in the loop was we emptied out the list. The last number remains when this is up here because we empty the list and then we do something to it. Does that make sense, Dom?
Yeah, I mean, it mostly makes
So
sense for me
how
too. I'm on the same
about
page with Dom.
oh, that's not going to be an index, that's going to be an item. And now this is going to, let me clear out the terminal. Now when I run through this, now this breaks down by adding this print statement, and this is what kind of what we call print debugging when we start putting print statements inside of loops or whatever so that we can see what's going on during the loop process. Okay, so what you see right here, all of these print statements is what's going on during the process. So the first number we know is our X, which is our number we get from the nums list. The next piece is what's currently in our list. Do you see that?
Yeah.
Do you see how it never has more than one number?
Yeah.
That's because each time we go through the list, it reset it.
Okay. I see
You
what
see
you
what I mean? And
Yeah.
this is why logic errors are hard. Okay. And loops are awesome.
That explained it better because showing the logic as to what the system is doing, and then it when you reset the list, because you obviously can when you append, it's going to go up to the last number because you reset. So it would be 10, but it's
Yep.
helpful to see like it like
That
because I'm thinking the list is if like when you print it, it was the whole list all the way
mhm.
out. I'm thinking it's resetting the whole list. So I'm not understanding like why 10 would be the number, but showing how the system runs like that, it makes sense.
Yes. And this is where sticking those print statements in helps you see what's going on. And this is actually a pretty good technique when you're learning these things, and loops is a great place to see this. I still use print debugging and loops when some of the logic's going wrong, and it's in I'm not like if I'm having difficulty tracking down stuff on paper or in my head. I mean, work smarter, not harder. Add a print statement in there, and let's look at the variable each time. So like when I take this out and we run it, we see everything we expected to see. And there's the difference right there. You can see the list growing.
Yeah.
Yeah.
I like the first example. That was the easiest to understand.
Yeah, this is kind of a caveat and just kind of a like a FYI that as you're working through exercises, this is if you're not getting the answer you're looking for, this is a good way to start kind of going. This is a good way to debug and figure out, okay, my item number is this, but in this particular case, why is that the only one in my list? And you start looking at other pieces of your code. So you can kind of hone in on whether you think it's the loop that's causing the problem or it's logic outside of the loop.
Yeah, now I get it though, because I was under the impression that like when you were resetting the list, like I'm figuring the list in my head the long way how it was printed the first time. So
Yeah,
my logic is that it should be getting rid of the whole list, but seeing the process of the way the system works, because obviously it's different than what I'm thinking. That last number being 10 when you append, that's what's going to stay because it gets rid of everything else.
right, right. Yeah, and it's lists can get tricky to try to track in your head. So I would just highly recommend it, especially while you're feeling them out, throwing those prints in there, even when it is working right, so you can see the pieces as they go through.
For sure.
Okay. Um, so this is effectively we're taking a loop and now we're starting to add logic to it. And this might be a place where the loop might make more sense because now we're doing even more to it. And this right here is a membership check, right?
Computer site. Also Reddit and social media.
And we're starting to add in a little more complicated if statements in here. I know we've covered these a bit.
I
Any
did
questions on this?
I did pretty well with the if and the elif statements or the else statements. It just threw me off with the numbers. So like now I understand like with the URLs, it's gonna like depending on what you punch in, if it's Apple or Dell, it's gonna give you the computer site. Or if it's Reddit or Facebook, obviously it's going to give you social media. And if nothing else, it's just going to say other site.
Right. And in this case, instead of us just looking at one of the values, now we're running through the entire list of URLs, and then we get something that resembles more of the kinds of programs we expect, right?
Yeah, that's like easier logic for me to understand. I don't know why the numbers were different.
Well, I did interject one of the most common types of errors that I've seen in my past when you're dealing with building out a for loop and then accidentally putting something in there that should have been wrapped in an if statement. So
Sure.
like if you wanted a certain number to be excluded, I'll show you how that's part of um today's lesson as well is there's ways to just do nothing or um drop completely out of the loop. So you have a lot of different control over how it's going and stuff.
Five print hello.
Okay, so
The easiest one for me to understand with the loops was like your typical username and login, how that worked, like with the for loop.
Is that a later example here?
Um, so for me, I was doing it on solo learn.
Okay, okay.
What I think it's a for loop, or it might be no, it's an if.
That might be an if statement's what it
Yeah, it
sounds
is an
like.
if
Yeah.
statement. Yeah.
Okay. So we see this statement here. In theory, it looks like you could do that given what we've done, what we just did, as far as like for URL in URLs. But that's not exactly how the Python syntax works. So when we're specifying numbers, we need to use the keyword range. So if we
And this is only for numbers.
this is usually with this is to deal with, usually you use this with numbers. Um, there's other places where you might, we'll touch the more complicated stuff as we roll. Let's go with numbers first, all right?
Okay.
Yeah, that I don't want to overstep the way the curriculum was worked out either. So if we want to loop through a range,
It's gonna
should
yeah, it's gonna go all the way up until 5 and stop.
right. It goes through 5 elements, and we know we start at 0.
And this is how
If
you stop the loop.
no, this is it ran completely through the loop. We will cover stopping or short circuiting the loop, if you will, uh later on in this lesson.
I guess what maybe I said it wrong is like it doesn't stop the loop, but that's like the total that's in this loop. So like it will take it all the way up until 4, but not past.
Right. And what I did, I just added the +1.
Yeah.
So if you want to see it the way you're used to counting, that's all you would do.
Yeah.
And as we see in this example here, we've got 3 different possible arguments we can give it. So if we want to count to, we'll count to 50, but we'll count every other number. How about I drop that down to 10 so that it stays all on one line? There we go. So we're specifying the step here because we don't have to go, one item at a time. If we know for some for depending on what we're looking at, maybe we're looking for every other element or something like that, then we can go about it this way. Does that make sense?
Yeah. So the number that would be following, so your range is 0 to 10, and then any number that would follow that would be what it's
Our step. Yeah. The
okay.
step we want to take. Yeah. So
That's what I was gonna ask.
if I change this to 3, then we get counting by
All right,
threes
makes
and
sense.
that sort of
Makes
thing.
sense.
Yeah.
Makes sense.
So this breaks down basically everything that we were just talking about.
That's pretty self-explanatory.
It didn't pull 10 because 10's not a multiple of 3.
Well, I think he's saying for the 2 when you had it going by 2. I was kind of curious about that too, but then if it's within the range, it's going to stop before 10, so it'd put it
Oh,
at
because
9.
10 is 9. Yes.
Yeah, yeah. All right.
If you wanted to see that, this will count the odd numbers. See, if we wanted to
That's where
include,
you'd put the +1 at that for
not
print.
exactly, that would give us the odd numbers. But if we want the even numbers, and this stop is exclusive. So it excludes the number 10 because that's the index we're hitting. So if we wanted to include the number 10, add 1 to your stop.
Because if you just for like example, if you added plus one, like print I plus one in the parentheses, would it give you 12 at that point?
If I went through and did
Yeah,
the
if you
11,
had it just like that.
oh, like
No,
this. Okay.
with 10. Would it give you
Okay.
12 at the end?
No, it gives me 10. I added +2 here. Sorry. The logic was working out in my head already. There we go. Now we have the odd numbers.
One, three,
You
five,
see?
7, 9.
Because
I that
our
that
our original numbers were 0, 2, 4, 6, 8, right? If
yeah.
we add 1 to those, it's just a left shift. So 1 plus 0 is 1 and all the way down through the line, right? If we change that to 2,
Okay.
then we get the even count excluding 0.
Okay. Yeah, that's what I was
It
curious.
does take a little bit to play with and get used to. I
That's
do
one of
admit
them
that.
for
Yeah.
yeah, that's one of them for sure.
We've already done this example. We've gone through. Okay, so this is a different example of how we can use the loops.
I don't mean to sound illiterate for a second, but enumerate, what is that?
Enumerate.
What is that?
Enumerate is it's a function which takes and in this particular example, we're generating an index. Yes. Yes, Marcellus. It counts our elements. So enumerate gives us the count or the index. So that's why this is labeled out this way.
I've never even heard enumerate as a word.
To be honest, outside of Python, I haven't either. Oh, I should.
I need to look up like what the definition of that means.
I'm doing this the hard way, but one key thing. Yeah, it effectively means count the elements. It's kind of like using the len function. However, if we use the len function, we would only get the number.
Okay, so basically it's to mention one by one.
Effectively, yes.
Okay.
But this, I'm glad they used the actual variable name index here. It helps you understand what we're getting. So when we run this, we get both the index number and what is in that location.
That makes
So
sense.
the enumerate is what gives us the index number. So that's what gives us the index number. And then the fruit is the element in that index.
Which would print the bananas, apples, and cherries thereafter the index.
Yes.
Okay, that makes sense.
Now, this is less this there's a style choice here because you can do this way too. Now remember what the len function did. So we print. This will be a little less readable too. And see how that gave the same answer. Do you see the difference between these two how these two were constructed? Now, I do realize that we're chaining stuff here. We're chaining.
No, not necessarily. I don't. There, 1, 2, bananas, apples, cherries. Bananas, cherries.
So what we're doing here, now I'm going to comment out just this for loop. And what we're going to do is we're going to see.
So is it effectively just like counting out how many are in the index and then indexing, well, giving you the values of bananas, apples, and cherries in this, like the next one? Is that
Yeah,
what's
with this
happening?
one, this is okay. So this is the way we've been accessing lists up until this point, right?
Yeah.
We give it an index number, and that's how we access the element. So that's why I added this up here. I printed out the length. So you can see the length is 3. So what we've done is we've changed this into range 3, right? So now we're going to count. We're going to count 0, 1, 2. And that's what's going to be assigned to index. And because we know that we can use that index number to access the element, we use the notation that we're familiar with and put it that way. There are two different methods to do the exact same thing.
Yeah, I was gonna say the second example seems like a little bit, at least for me, redundant when like you can do the first one and it calls for the exact.
Right. Yes.
It just seems like the second one is a lot more
So
intricate for no reason.
like if you're working through loops and you forget about the enumerate function, this is probably how you'd end up doing it. You see what I mean?
Yeah.
It's not wrong. It does the exact same thing. But this goes back to when we were talking about there's more than one way to accomplish a solution. Did I lose anybody there or everybody good?
I'm tracking.
All right, we're going to take a break. I think this is the first time I've been on time and can come back at. Okay, so as we saw, these are two different ways to do the same thing. And pretty much you use what's comfortable. This is easier to read for some cases, but functionally they do the same thing. Okay, so now we've seen how we can pull two different values from one loop. So this index is whatever number our enumerate gives us, and the fruit is the element from fruits that we're looking for. So we can build on that with dictionaries. Iterating through dictionaries, obviously, we don't have an index. So how do we do that? Well, that's what we have right here. Now, does it just really quick to see if anybody remembers, does anybody remember what the items method for a dictionary gives you?
What's listed in the dictionary?
Is it the
You
key?
can
Well,
print everything that's listed in the dictionary just by printing phones in this case. So here, what I'm gonna do while we try to see if, while we're working this out, I'm gonna comment out this logic. So if we print phones, we get the whole dictionary, right? We have the curly brackets, we have the key, value, comma, key, value, key, and so on. Everybody got that?
Yeah.
So you were thinking, now I missed who said what did you think the items would give you?
I thought it would return the key back.
Well, the keys keyword will do that. So if we go, there we go.
Would you be
So,
calling for like a specific item in the dictionary with
well,
item?
our goal is to iterate through the dictionary, right?
Yeah.
And we want the key and the value. So keys gives us the keys. What would items give us? You guys remember? I remember, I know we just covered this on Monday and we
Yeah,
just
no,
got into
I'm
dictionaries.
spacing it on this.
No worries. So if I output items, this will give me,
Oh, I think I remember.
I know we didn't touch it very much, but it
Was
gives
it
us
was this like
tuples.
the example for like the license where it's like your key would be like sex, height, and everything like that, and then your items would be what's listed with those?
No, okay, so those are values.
Okay.
Okay,
Yeah,
so
I'm off then.
if we printed, there we go. Yes, Laramie's got it. What it is it's a tuple. Remember the parentheses is a tuple, parentheses with a comma. It's got the key on one side and the value on the other.
Okay.
Okay. So one of the I'd say one of the most recommended ways to go through a dictionary is to use the items when you need both from the dictionary. So in this particular case, they have K here. So if I'm going to rename that because we shouldn't be dealing with shorthand right yet, so we can understand where we are. Now, does this make sense?
Key value.
What
Info.
we're doing now, this is called unpacking.
That's where
So
my head kind of
each
went.
we're iterating through each element of items, which this is an element of items. Now notice items is a list. So now we're iterating through a list. Does that make sense?
Yeah, I just don't like this.
It's a bit tricky, but once you get the hang of it, it does feel easy after a bit. So when we run this, what's happening is this tuple is unpacked and it into whatever format we have here. And this is going positional. Sorry about the pop-ups. So this key lines up with Francisco, and this value lines up
With the
with the
number.
phone number. And it does that all the way through items because it's looking for these commas. Does that make a little more sense? This is a pretty complex kind of thing when you're working through it.
I understand like the process and like the output, but like when you are putting in that syntax, that's where I start getting confused as to what you're calling for.
This syntax right here, or the terminology I'm using to describe it.
I would say probably both. So the key is obviously going to be the name, the value is going to be the number, and then phones is the variable that's stored with the key and the values.
Yes, phones is up here. Right here's phones. That's the dictionary.
Okay, so yeah,
Let me
that
let
makes sense.
me, you know what? It's always easier. I prefer to define dictionaries this way so you can look at it and we're like, "Oh, I know I'm dealing with a dictionary here." So the phones is the dictionary we're working with. Sorry, that wasn't
No,
it doesn't
it's not
wrap
your fault.
very
It's not
well.
your fault at all. This is just like my brain.
Yeah, see, I have my own editor that auto wraps the stuff, and sometimes I'm not thinking about that. Like this line right here is not auto wrapped.
So yeah, see, I miss the tuple part, and like going back through the tuples are pretty hard for me. So that's kind of why I'm spacing it here.
Well, the tuple is an ah, immutable ordered data structure.
And
So
that
what?
means that you're able to change it.
No,
Immutable?
immutable means we cannot change it. But in this particular case, we're not looking to change it.
Okay.
We're just looking to output the information. If we were
Yeah,
looking
no,
to
I got
change it,
that now.
we'd have to do this a different way.
I got it. It makes sense now.
Yeah. And then the 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 unpacking part is there's a lot of places where it's used, and this is the first time we've kind of actually seen it, where we're taking the tuple, taking it apart, and putting it into specific variables. And then we can do things with that variable. The tuple we can't change, but these are now strings, so we could change those if we wanted to.
So basically, you could change their numbers.
Yeah,
Okay, I get it. I get it.
but this is a way to go through the whole dictionary, grabbing the key and the value. You could you could access. Yeah, it's not going to work if I try modifying that way. Um, I'd have to go through this a different way if I wanted to change the value, because as soon as if I change the dictionary value inside this loop, value is already assigned, so it wouldn't really do anything. It would the next time I ran through it, if I ran through another loop or something, but there's another way to handle that sort of thing. So, um,
Yeah, I'm not there yet. I'm just like got the understanding of this.
okay, yeah. So this is just one of the basic ways to go through. Um, now that we knowing that like using items and keys gives us a list, we can start using the ideas that we were using before to go through lists to go through those pieces. It's a little bit more complicated, and I don't believe, no, it's going into while loops. So if we run into an instance of like that in any of the assignments, I can go through and elaborate more on that. But for now, we'll worry about this being the way we go through dictionaries. Okay.
Yeah.
Um, we have the when to choose. So here's a good few use cases on what style of for loop you'd want to build, depending on what you're looking for.
Yeah, a lot
Nat,
of a lot of this stuff is definitely like the repetition for me because like when you go back it through and explain it to me, I understand it and I remember it. But
mhm.
trying to memorize, I'm not trying to memorize all of it. I'm just trying to get the understanding. But like trying to memorize the exact like way to index and the expected output is kind of where I get a little off. But that's I think because I'm like so
After practicing, yeah,
yeah.
after practicing a little bit and being able to tweak it yourself, that's why code along and the practice, the assignments, the exercises, that's why they're so valuable, is you're getting your fingers in. And that's the other reason why we don't have an answer key sitting in there for these things. Because, well, like we saw before, multiple
And
ways
the
to do this
commissioner's
stuff.
on the floor looking at the scale. There's a second lady.
Could somebody
I
mute?
look down and she's right next to him, so I can grab
I
the
don't.
towel. Like, shit, we all agree.
Marcella's got something going on over there, bro. We need to send help.
Oh, sorry about that.
Okay, so that's for for loops. Now there's another style of loop that's structured a little bit differently, and that's the while loop. Oh, this is the first place they're actually importing stuff. I'm not going to dive I'm not going to dive into this import statement right now. But I do remember somebody was talking about random number generator the other day, and I had mentioned the random library. That's what this is, and you can see that that brings this function random in, where we can generate a random number. So one of the differences between, let me see here. There we go. One of the differences between while loops and for loops is, you see this progress number right here? Well, you see both of these actually. With while loops, outside of the loop, we have to initialize our counter. So our counter in these, in the for loop here, our counters okay, so this is a bad example. I need to use a simple example.
Yeah, I was gonna say, dumb this down for me.
No, this is the wrong example. We need the range. There. Okay, so what we're initializing is this logic over here. So this, where we're getting this range, which in this case is 3, we initialize, no, this is our 0. This is where we start at the 0. Okay, so we have a Boolean statement here. While a while statement is always a Boolean statement, and our progress is set to 0. So that's kind of like starting our index at 0. And then our file size is like our length fruits right here.
Makes sense.
All right. Does that work for everybody?
That makes sense. I'm just confused on the progress part because +1 or equal to.
Okay, so this right here, I don't know. Did we cover increments?
No, I don't think so.
Okay, so what this right here means is progress equals progress plus 1. This is a shorthand way to write it. That should actually be included in our operators. That is a very handy one.
So if that's the case, then progress would be equal to 1.
So once we hit this line, yes, progress equals 1. And then we start running through our conditional logic. If 1 equals round, so whatever it's doing is it's rounding the file size, which is this number. We're dividing it in half and then rounding it. Okay. And this is a random integer somewhere between, what is that? 1 million and 20 million.
Yeah.
And then we
should be
print
like,
some output. If we hit this conditional.
Print file is 50% full.
Yeah, so it's halfway through the file size.
Oh, okay.
So we're saying it's halfway full. So
Gotcha.
right here, it does the same thing. We're checking if we're 75% through, and the file is 75% through. But these are equal, so it only hits that once. And then it just keeps on looping, and it keeps adding. So some differences that we see is we have to initialize our variables outside of the loop, and we also have to make sure we increment our counter inside the loop. If we don't do that, we're going to run
loop.
It's an infinite loop, and what'll happen is we'll run out of memory.
Yeah. That's where I kind of got thrown with loops, is making sure you put the correct syntax in order to either continue the loop or to stop the loop so it's not an infinity loop.
These are the basics behind preventing an infinite loop. Uh, a lot of times, sometimes I do it myself. Sometimes I forget to put the incrementer in there. And you start seeing it spin for even like running on your desktop machine or your laptop, seeing it run for like 30 seconds and it shouldn't be doing that. You just hit the break key sequence, which is Control C, and you stop the program. And then you go figure out. It usually tells you I forgot to increment something or I'm not checking something properly.
That's what I was gonna say. I mean,
Yeah.
if you got to that point, it'd probably throw an error or something.
Well, it'll run until it runs out of memory, and then it'll tell you it's out of memory.
Huh.
So another way to mess this up is reversing this sign.
Yeah,
Reversing your
I
Boolean
remember
logic.
that. Yeah.
Yeah. So if you reverse the Boolean logic, you'll still
That'll
run
create
into
the
an infinite
infinity
loop.
loop. Yeah.
Yeah. So there's two different things you can do. While loops, you definitely have to be more careful than for loops.
Is
Because
that for anything? So, like, if you switch the less than sign from progress to file size, because you're basically would be stating that progress is more than the file size. I guess what I'm getting after is if you point that towards the variable as
oh
opposed.
no. Okay, that's right. If I flip it, so that one's not an infinite loop. I'm sorry, I explained that wrong. If I flip that sign, the loop won't run
Okay.
because progress starts at 0. And if I'm looking, if progress is greater than file size,
That's what creates it.
let me double check here.
Because this is where I got confused with loops, is like the infinite loop part.
Okay, oh, there, you see that took some time. Now, if I flip this, it ran once, right? Yes, it ran once, but it never hit any of these. So it printed the file size, but because I'm checking the wrong Boolean logic,
It doesn't get to the
it doesn't go
one.
inside the loop because this loop runs while this is true. As soon as it's false,
So
it's done running the loop.
with this particular statement, you wouldn't be able to create the infinity loop.
Oh yeah, I can. If I comment this, that's going to infinitely run. Because
So while this isn't loading, this is where you would like pump
yeah,
the brakes and be like, okay, I fucked
yep,
up somewhere.
yep. And that's where the keyboard intercept comes from.
Gotcha.
Means
Okay.
I interrupted the program. The reason why is because progress never changes. Because I commented out the only line that changed progress. So progress is always 0. It's always less than file size. So it continues to run.
Yeah. Okay, I kind of get a better understanding because like when I did this, it was like the equivalent to I think the example was like a thermostat for your air conditioning, or no, it was a thermostat for outside, and if like it was colder than 50 or whatever, and then I started playing with the values of it, and then getting into like the if and that like those loops to create an infinity loop or see where it stops or like how it runs.
Okay.
This was pretty confusing for me.
It a lot of times, you start learning it a lot. It starts making more sense in your head when you actually create an infinite loop, and then you got to go figure out what caused it.
Yeah,
Yeah.
that was kind of the vibe that I got from it.
Yeah, that's one of those instances where I was talking about a lot of the stuff I've learned was by breaking it. While loops are definitely one of those.
Gotcha.
I've definitely made more than my fair share of infinite loops.
Gotcha.
Okay, so we were talking about any questions on while loops while we're at it here. Okay. So we were talking about different ways to change like early termination or change how we're running through the loops. But we really didn't dive that deep into that deep into those. That's what this section is. Break and continue are two keywords that we can use inside for or while loops to be able to short circuit or change the way we're going through the loop. Any questions there? Copy this in here. So the break statement, when we're running through the loop, that completely terminates the loop. It doesn't matter how many, in this particular example, it doesn't matter how many students are left, we're done. So like in this case, our message is when we run out of cookies. So when we don't have any more cookies, there's no reason to continue to go through the loop. Any questions there? We see that we stopped at Kevin and we never hit Greg.
Sorry, students.
Everybody see that? Any questions there?
So I have a dumb question. So why is the break statement needed in this particular for loop?
Because we have 9 cookies.
And there's 10 students.
There's 10, is it 10? Yes, there's 10 students, and each time, as long as we have more than 0 cookies, we give a student a cookie and decrement our cookies by 1. There's that minus equals. So your plus equals is +1. Or cookies, this turns into cookies equals cookies minus 1.
Okay, so this is getting to where like I was having the problems. So like if you change cookies to 10, so where your value is 9, and if you change cookies where it's 1.
Hold on. Let's take this one step at a time. This is one of the key things when you want to change the behavior of a program. Always try to just change one thing at a time so you can isolate what's going on. Okay?
Okay, so we change it to 10.
So we run this, we change this to 10.
Now Greg doesn't get a cookie.
Now Greg doesn't get a cookie. So instead of Kevin and Greg not getting cookies, oops. So if we change that to 11,
everybody gets a cookie.
So, okay.
Then
so
the break statement wouldn't be needed.
I see what Miss Erlis is asking. Wouldn't it just end naturally? So let me comment out the break and put this back to 9 because we're only going to change one thing at a time. And let's see what it happens. Notice how we have 2 messages stating that we don't have any more cookies, right?
Yeah.
What's the point in telling Greg that we're out of cookies? We already checked if we don't have any cookies. We're just wasting time now.
Yeah.
That's the reason why we put these statements in here. We want to just hurry up. If we've got a whole bunch of other stuff going through, we don't need, and we've got 100 students and only 9 cookies. We don't want to run through this, 91 more times.
So basically it would print that statement for the last 2 people not getting cookies. And then if we didn't have the
it makes no sense to continue going through the loop. We have no more cookies.
So how would we change it again to where it's like, okay, so I guess it would be Kevin that didn't get the cookie, and then the print statement for Greg wouldn't be there because we've already said that we're out of cookies.
Yeah.
What would need to be changed is taking out the
Oh, I already what it was the break statement.
okay.
So by taking out the break statement, we tell everybody who's left we don't have a cookie. So
Okay, so when we
let's
add
do
the
this.
break statement, that's
So this is might be a little more. Let's use a really small amount of cookies. We only have 3 cookies. But we've gone through and we've checked
okay.
for everybody.
So the
Okay.
break statement would shut it off at the first one.
It short circuits it because once we know we don't have any more cookies, there's no point in checking anybody else. Yeah.
Okay. That makes sense.
That good for everybody?
I like this stuff.
All right. I am going to we'll take a break here. All right. So we covered break. The next statement that we can use to modify how we go through a loop is continue. So in this example, sometimes we don't want to bail out of the loop. We just want to short circuit processing of whatever element we're on, depending on, whatever our criteria might be. So let me clear this out. I'll run this. And you should be able to see, so we have the full list of all the students. And now we have this other list of those who completed the survey. So for our conditional, we're checking if our current student is in this completed survey list. If they are, we jump to the next student. If they're not, we print out the you need to complete a survey. It's pretty simple and works a lot like the break, except we're going to continue going through the entire list. Any questions on that? So effectively, you can remember like the break statement breaks the loop. So we break out of it. The continue, you can kind of make that, you could kind of parallel that with skip, like it says right here, skip items. We have a couple more examples. We'll run this. Any questions with these so far? Okay. So we've already gone over turning each character into string. So we understand that we can run loops on iterables and we can use the enumerate or the range to be able to loop through things a different way. So this right here combines using the range based off the length of the list, and then we also add the break statement in. If our brand is a Chevrolet, if our brand is a Chevrolet, we're going to pop that brand and we're going to break out. In this particular instance, I believe this right here is just going to run once.
What is the len syntax again?
With len, you're getting the length.
Okay, that's right.
Yeah. always, yeah, you always put your variable you want the length for inside the parentheses for len. And I believe you should be able to get a len off of most, I believe just about all the variables. I don't think.
Break auto branch. What true?
Yeah, you can't get a length off a Boolean. But the rest of them you should be able to get a length off of. Any questions so far?
Can you run this one in practice, people? I want to see what happens.
Sure. So what we're doing, we start with the full list. We've added, we're running through the reason why we're going through the index this way is because we need that actual number so we can pop it. And that would be one of the reasons why we would use the range supplemented with a length to be able to go through this particular list, because we plan on using the index in another function. Does that make sense?
No.
So we're looking at Chevrolet here. So how about we take this and we put Jeep
Okay.
and we run through.
Tesla, Ford, Porsche.
Okay, so there we go. We've gone through, okay, so we're using pop itself takes the index of the item, the element we want to pop out of the list. And because we're only looking for, that makes sense, right?
Kind of.
Here, let me.
What? So what does pop do? Because I didn't hear about pop.
Pop was when we covered lists.
Okay.
So what pop does is it pops that element out of the list.
Okay.
So it also returns that element. So we could easily assign that to a variable if we wanted to capture it and use it for processing. So let's say we wanted to do processing on this Jeep, and maybe this auto brands is something that we still have yet to, that there's other things we want to do with these. Maybe we have, for this particular instance, we need to find just the Jeeps or the first Jeep and do something with that, but we don't want to touch any of the rest of the list. So we're using pop to be able to pull that item out of the list. And in this case, I just assigned it to my element because pop returns the element that we took out. If you don't assign it to a variable,
Okay.
then it's gone.
Okay. I got the warm and fuzzy on it.
Okay.
Yeah, I definitely still got more questions about it, but I don't want to hold this hostage here for 5 minutes.
Anybody else have questions on it? Okay. Now, similarly, we can go through coordinates or tuples, which a tuple, a good way you can kind of get around that is you could represent coordinates inside a tuple. But this breaks them down because you have a 0 element and a 1 element for this particular tuple. So we can print out each one. And this is the simple for loop that we saw. dictionaries. This one looks a little complicated. Okay. Any questions on the tuple? Okay, so that's a long string. I believe the way you specify how to wrap is in the edit, which I don't have access to that bar, do I? Yes. There we go. Okay, so what we're doing here, we'll run through this, clear it out. We'll run through this and then we'll walk through the logic. So what we're doing with the attribute is we're getting the key from person. So if we just print see what that variable looks like on its own. And there we are. So when we supply the for loop with a dictionary and just put one variable, by default, it pulls the key. Everybody see that? So what we're doing in this case, we have the attribute right here. And that's where they're capitalizing the attribute. And to be able to access the element, the way this is going through is we are typecasting whatever is in. Okay, so we're getting person and supplying the attribute, which is our key, which that in the name instance returns Alice. And we're going to typecast it to a string, not because of Alice, but because we know we have non-string variables in here. And the reason why we need to typecast it is because we plan on using the upper method. If we didn't want to use the upper method, we wouldn't have to typecast this. Does that make sense?
It does. So you're covering your bases. So for your values, even though you know Alice, excuse me, is a string, you also know 25 is not a string. So you're just covering your bases pretty much with that.
Yes. Yeah. If basically if you know that there are no strings, or if you don't know what the value could be, you could typecast it just to, like you said, cover your bases so you don't run into just a goofy kind of error. But yeah. I realize this one's kind of a little bit complicated because we saw the earlier example of unpacking, and that might have been the better method, but this shows another way to do that same operation. But as you see, it can look a little confusing when you're trying to read it. Any questions?
I had one. So by default, I know you said when it says for attribute. So by default, when you say attribute, because I know person is the actual variable, the attribute it is going to default and say, okay, I know this is the key.
Yeah, because person is a dictionary and you've only supplied one variable. So by default, it's going to, well, because we haven't accessed the items method either. If we went through and we did items, an added value, we should be able to print the value, right? No. Okay, so items is not capitalized. There we go. So by default, if we just give it the dictionary, then when we go through and when we iterate through the dictionary, we're just getting the key. So it's showing an alternate way to be able to go through and get the same information. We could do, I'm going to copy this in here. And this is just to demonstrate the difference between the two methods, yet they do the same thing. So what we're going to do here, we still typecast, but we can put value instead. And we still get the same here. Let me. All right, does everybody see that? We used this unpacking method earlier when we went through the dictionary. And this method and this example here shows a way of going through the dictionary by just getting the key. Generally, it's a good generally this is one of the things you want to think about when you're building your loop. If I need both the key and the value, it might be just it might make it it does make it easier to just pull in, just kind of use the items method and unpack it. Because now instead of looking up person attribute, you know that you have the value. Everybody see the difference there?
I'm not even gonna lie to you. This is like completely going over my head. I'm having a hard time with this.
All right, so let's back up. So do you see what we're doing here, right?
Attribute in person print. This is key. Attribute upper, and this is value. String person attribute upper. Yeah, kind of.
Let me stretch this out. Does that make it easier to see?
Yeah.
So this is the part that I was talking about right here.
Person set attribute. So we're getting into Alice and her information.
Yeah, so this is name. Attribute turns into name, right?
Okay.
And the name is the key to this element of the dictionary, right?
Yeah.
So by supplying attribute here to person,
You're reassigning it.
no, we're not reassigning it. We're getting the value for name.
Where does where I'm confused at right now is where name, well, attribute gets reassigned to name.
Yes, because this loop for the first part of the loop, the first time we go through, attribute is name. Okay, so this is name now. This is name, but we're going to take and we're going to run the upper method on name to
Okay.
capitalize it.
Yeah.
Then we want that value that's associated with that key or name. So we take the person dictionary and we supply an attribute, which is name in this case, and that gives us Alice. Okay. which we have Alice right here.
I'm doing I'm doing the best I can to like track what like how that just happened, but I don't
So
want to hold
instead
this
of,
a hostage here,
well,
but it's definitely
well,
confusing the shit out of me.
this is where the power, this is where we're using, this is where loops are kind of showing how powerful they are and whatnot.
Okay.
So in this particular case, if you wanted to print you could go print person name. We're used to that syntax, right?
Yeah.
And we know if we do that, it's going to be Alice.
Okay.
So now, instead of telling it we want this specific value, we want to get all of the values. We want to get all of the keys one by one down through the list, down through the dictionary. Okay. And this doesn't matter how many keys we have. We can have 6 keys, we can have 6,000 keys. It's going to go through all of them. Okay. So instead of specifying name, we're using the variable attribute, which on the first run is name, on the second run it's age, on the third run it's occupation, on the fourth run it's salary, and on the last run it's division, right?
Yeah.
But to get our values inside a dictionary, we have to give the key, right?
Uh-huh.
That's what we're doing right here. So we have the dictionary name, which is person, and then we have to give it the key. The key is the variable that we're using to go through the loop. Is that tracking? So both of these, where it says attribute, on the first run, both of these are name.
Yeah.
So this right here on the first run is the same thing as this right here.
Okay.
We're used to manually going through this stuff, and now I'm showing you a way to automatically go through it. So instead of going through and typing it out this way,
Yeah.
instead of doing that, you see how much this is starting to get long, right? And this is
Yeah.
2 lines. And this requires us to know what the key is. This doesn't. The key can be anything as long as it's a string. Does that make sense? In this
Better than
particular
it did.
example.
Better than it
Okay.
did when I started, but I don't want to hold this hostage here. This is something that I'm going to need like horrifically dumbed down because this is really confusing for me.
All right. Yeah, we could work through that. How much more do we have here? Yeah, we're just about done here. Thank you, Corey. The attendance link is inside the meeting chat if everybody could knock that out. I'm going to step to the next example. Well, this is another example of going through the dictionary, but we're going through the values. So if I run this will just print all the values. It doesn't give us any of the keys. Everybody see that?
Yeah.
Okay. On the same token, we could easily just switch that to keys. We get the keys. And if we do items with one variable, that's going to give us the tuples. Everybody see that?
Yeah.
No, and this is exactly what I was just going over. So they do continue to cover through this, so we can spend some more time on it. Because it does get a little tricky. I'm not gonna lie. There we go.
Yeah, I don't like this at all. This is I would say probably the biggest roadblock that I've had this far.
The destructuring part
Yeah.
or the unpacking,
Yeah.
it does.
It probably has to do some with like me being tired and not fresh right now, but like I would say this
Yeah,
is probably
that
the
very well could
one.
be because it is. Yeah. Um, Effectively, when you've got some time to review it again, this section right here that we're looking at
Yeah.
does the same thing as this section up here. And that might be that might be where there's a little bit of difficulty. The difference is how we're calling the dictionary. We're calling the dictionary here, and by default, it just gives us the key when we give it one variable. To get both variables, we need to call the items. So like when we printed the items, we see that we got the tuples. So it breaks them apart. And I understand that it takes a little bit to kind of wrap your brain around stepping away from actually calling out each dictionary piece this way and kind of looking through the dictionary structure and seeing where it's getting its pieces from. So like we know that's the key and that's the value. I agree, Laramie. This right here is my preferred method of to go through. If I know I need both the key and the value, I prefer to shortcut it and just call it key and value so I know what I'm dealing with. This right here, and yeah, if you've been staring at it a while and stuff, this might start messing with your head and that sort of thing. Which very well could be what's going on, right?
Yeah, for sure. I mean, I'm just like trying to like piecemeal it together with like what's there, and I can't like really. If I had to be honest, if I had to do this right now in my own programming, I'm printing every single thing out and I'm going to copy it and paste it into ChatGPT and tell it to shorten it for me because I just don't get it.
Yeah, what I would do is I'd ask it to explain it to you.
Yeah,
Yeah.
probably both. Like, give me a shortened version and explain it to me.
This is the shortened version.
Yeah.
That's what I mean.
Well, yeah. I mean, if I didn't have you here shorten it for me, you know, I definitely. And I was running my own program. I'm definitely telling ChatGPT to shorten it for me and explain it.
Yeah, I think the biggest piece is kind of bridging that gap from jumping from, person with the name in the brackets to understanding that this is exactly that right there. Because now we're using a variable instead. So we could easily go about it and do just like this, actually. So if I go key equals name, right?
Yeah.
And then I go print person key. Okay.
Yeah.
So we know there is no key called key in here, right?
No.
And we know this is a variable.
Yeah.
So when I print that, it gets Alice because key is assigned to name.
Yeah. Yeah.
So that's what this is doing. The first run through, attribute equals name. So this right here should be called key.
That makes a lot more sense.
So the variable naming might be what was kind of throwing you off.
Yeah, probably because I'm seeing person and then I'm seeing like the attributes and I'm trying to put one and two
Yeah.
together how it's changing from one to one.
So there's a very, very good lesson in what looks like clever naming for variables.
Mm-hmm.
We write code for other people to read it, right?
Yeah, of course.
And like these two examples, they tell you exactly what I intend to do with them, right?
Yeah.
So yeah, maybe that's the key right there is name it what it is. It's the key,
Yeah, I
right?
think I think because I mean like obviously probably Laramie and Corey are more versed in this, so it makes a lot more sense to them. But for me, because I'm going off basically like what I've been taught completely green, I know it is key. And then where I'm trying to put it to is like how is person, and then once you put attribute, kind of unpacking it how it is. And that's where
Mhm.
I'm kind of getting hung up on starting to overthink it. But like when you put key in person, I
It
it
starts help. This is what I'm looking for in person. Yeah. And
yeah,
that's that's the kind of way I like to approach this stuff. Yes, naming is one of the hardest things in programming. Thank you, Laramie. Because for who wrote that particular example, attribute made perfect sense to them to put it there, right?
yeah,
But where the difficulty comes in is when other people come in and they try to read your code, and when they're trying to figure out, okay, what are you doing here? Especially, like you said, when you're new and you're trying to wrap your brain around things, we need to really make sure we're paying attention to what we're calling our variable names. I think that's when I used to use long variable names when I was really, really new. And sometimes I would write those long variables out. And I'd be like, okay, is when I get to understanding this better, I'll write more shortened versions of that. But they still have to be, they still have to kind of convey the message. You know what I mean?
yeah,
So like we can kind of look at this K and the V and understand, well, that's a key and value, right? But
yeah.
I do agree, attribute is kind of confusing because a key could be an attribute, a value could be an attribute. It depends on what you're looking at,
And
right?
that's where I think I got hung
Hmm.
up the most is with that.
Understandable. At least by, hey, sometimes it's that easy. It just by choosing a better name might make something a little more clear.
Yeah.
All right. So we've explored lists, right? You can nest lists inside lists just like you can nest if statements inside if statements. And let's see here. This is using, this is using a list with two nested lists. You see that? And what we're going to do, so if you remember how we access this, what we need to do to access, we're going to say the first value of the first list. So we want to access the first list, which is element 0, and then we want to access the first number. Everybody see that? You remember that? I know this does get tricky. I do understand that. So I know we covered this a little bit, but that's how we get this one, because we have two lists inside here. So we have to add another index. If I get rid of this 0, if I get rid of that index, what I get is the first full list. That makes sense to everybody?
Yeah, that does.
Okay.
'Cause that's what's in the brackets, and then
To get inside there,
that's clarifying the first list. So then that
right.
would
So
be the
now
second list.
yep. And now I'm getting the 2.
Yeah.
Okay. So now that we got that, that's the reason why we have a for loop and then a nested for loop. I'm going to run this. Let me clear this out. And do you see what that did?
Punched out both lists.
Okay.
That's a list for item in row.
So the first time we go through this, the row is 0, right?
So item is basically the index
Let
of
me do
what's in
this.
total, right?
This might make more sense formatting it like this. Okay, so now you see that's the row, right?
Yeah.
What we can do is we can rename this to column. So for the first row, this outside loop only runs twice because we have a 0 and a 1. You follow me?
Yeah.
So there's only 2 rows, but we have 3 columns in each. Okay? So we get 1 because row is 0 and column is 0 the first time, right?
Yeah.
So this turns into print 0, 0. Okay. This is just the first run. But what it's going to do is this is where the variables are coming in. Do you see the connection there?
Yeah.
So when this is 1, that's 0, 1, and that's how we get to 2, right?
Yeah.
And then this is effectively how you trace through. No. Yeah. No, this is 2, right? So 2 is the last element. We have no more elements. So then we jump back up to row. And now this is 1. And we go back to 0 here. Does that make sense? That's how it's able to go through all of it.
I mean, I got the warm and fuzzy on it. Honestly, I'm just
The nested
exhausted right now.
nested for loops are a little tricky. Usually you try to avoid them whenever you can,
Okay.
because what it does is it there's other concepts that it touches on that we're not going to touch in here. It has to do with how fast, how intensive your program's running and everything. And as you start building nesting for loops, it processes and processes and processes because it goes through every single element. And depending on what you're doing, you might be touching, you know, um, this this particular example is probably the main reason why you would use a nested loop, is because you have nested lists. And a lot of time, I mean, I think one of the biggest examples that I've seen in programming problems for a use case for nested lists is like a tic-tac-toe board or a chessboard. Okay. And something like this sort of check might be going through to check if you won the game or not. You see what I mean?
Yeah.
It's a lot more complicated than this, but you're checking for which ones are X's and which ones are O's, which ones are blanks. And that's the kind of use case for going through things like this. There's other methods to that, but we're not going to touch on that kind of complicated stuff in here. But this one, you can kind of, you can, this does kind of break it down. Maybe when you get some time, look at it when you got a little bit more fresh eyes, if that helps.
Yeah.
And okay, so data manipulation, there's this data presentation thing. There's some built-in methods that we have here. And what we're going to do, I'm going to throw this in here, clear this out. And we'll just run this as is. I know this print right here, this, it's going to do kind of like how it reads. All right. I've mainly seen this in Python. I'm not so sure on a lot of other languages, but definitely Python, where this is going to take this character and print it 15 times. Does that make sense?
Yeah, that does.
Yeah. So what that is that's this line right here. And that's for formatting. You see, they're going through, they've got a nested for loop to be able to break down this in a nice little readable style of chart or whatnot. And they're using nested for loops because each element of the set has a tuple in it. And what they want is they want it formatted so you're printing each one of the pairs on a separate line with the coordinate, right?
Yeah.
No, it's printing the straight coordinate pair.
Just rounded.
Oh, it's right here. It's going through the coordinate
Half.
pairs. So it gives you the raw coordinate pair, and then it's
Half.
rounding it underneath there to do extra processing on the same information.
So where it's got item equals round parentheses item slash 2, the 2 is halving.
No. Look at all these values here.
Oh, okay. So it's like indexing it 0, 1, 2, and then it's rounding that number.
2 decimal places.
Got you. All right.
Yeah, it's rounding it to 2 decimal places here.
All right.
Because if you look at the top value, we've got 6 decimal places on a lot of them, or in some cases a lot more. And it's just kind of it's prettying up the output and making it, if you don't need that degree of accuracy, why put it there?
Yeah. All right. That makes sense.
And they're using round instead of the truncate method that I showed earlier. So now it's actually like you could see.
So you
right
could just
here.
put round degree in there and it's going to understand that like you want to round it. I mean, that simple.
Right here. You see this function right here?
Yeah.
It's a round function. That's where it's actually converting the number.
Okay. So round degree.
And then now it's just item. Because we took item and we reassigned it.
Yeah.
So we started with item when we come in, and maybe it's 42.9, yada, 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 yada. So we reassign item to round it to 2 decimal places. We get 42.96, and then we just output it. This is just a print statement. It doesn't do any. All it does is it outputs to the screen.
Okay.
And the comma, we saw the F string, right? This is another way to add your variable on the end. We could easily do this with an F string and space it out this way. If we went with an F string, we would add the item that way. Okay.
Yeah, this topic specifically, I think is something I'm gonna have to catch with fresh eyes and
Okay.
kind of get after it like that because I'm tired and like I get like the warm and fuzzy on it, but
Yeah, that is the last part of today's lesson. If does anybody have any questions that they'd like to address now, or you want to poke at it for a little bit and we can talk about it tomorrow?
yeah, I'm about to hop off and we'll talk tomorrow about it because I got a ruck at 5 in the morning.
I
So
gotcha. Yeah, I hear you. Yeah, I got to be up at 4:30 too. Anyway.
yeah, so I'll definitely maybe we can start here tomorrow, just like a little refresher, and with fresh
Sure,
eyes, it'll
sure.
make sense.
We can go over a lot of these things. We'll when we get some time, kind of poke at it a little bit, and maybe we'll tweak the values and see what happens, that sort of thing. So, are there any other questions? All right, I'm going to end the recording.